Okay, this is the first example on intervals, and it says express each set given in set builder notation below in interval notation. So if you don't know what set builder notation is, make sure you watch my video on set builder notation and the roster method. So to convert the first set from set builder notation to interval notation, we have to take the limit. So the limit is x is greater than 3, but x is less than or equal to 5. So from the limit, that is where we are going to get the interval notation. So we know that since this side we just have a greater than, the type of bracket that we're going to use is this one. Then we have our -3, comma, our 5, and since we have a less than or equal to, there is an equal to here. The type of bracket that we're going to have this side is this one. Yeah. If you watched our video on intervals, you quickly understand what I've just done here. And for the second one, we get the limit again. The limit is saying x is greater than 5. Okay. So since we have a greater than without an equal to, our bracket is going to be like this. Then we will have our 5, and since we are saying x is greater than 5, it is just going and going and going. It's going to be comma infinity since it's going to the positive side. And when we have an infinity, the bracket is always this type. So in the number line, this would look like this. So you have 5 here, an open circle, then just going this side towards infinity. For the first one, on the number line, it would look like this. Let's say -3, 5 is here, maybe 0 is here, 1, 2, 3, 4. 1, 2 is a negative. This would have an open circle here, a closed circle here, and this would be our set. Okay, so that's how you solve the first example. Let's quickly look at the second example. The second example says, let the universal set be a set of real numbers. Also, let A be equal to that and B be equal to that. Right. So since the universal set is a set of real numbers, you have to present it on a number line. And the first question says, find a complement. So the first thing that we have to do for us to find a complement is come up with a number line. And so we have 0, 1, 2, 3, 4, 5. -1, -2, -3, -4. Okay, so we have to write A on this number line, and presenting A on this number line, it's going to look like this. Where there is 1, we are going to have a closed circle due to the type of bracket that is at the beginning. And where there is 4, we are going to have an open circle due to this type of bracket that we have. So this is going to be A. Now to find a complement is just the rest of this part which is not part of A. So to write that, this side, since 1 is included in A complement, it's not going to be included. So A complement is going this side. This is A complement. And on the other side, since 4 is not included in A complement, it's going to be included like this. So this is also A complement. So now to write this in interval notation, A complement is going to be equal to negative infinity. Since this side we are going towards negative infinity, so we have negative infinity, we have positive infinity this side, right? Comma 1, and the type of bracket is going to be this one, since we are saying 1 is not included. Since there is a gap here, we are going to say union, okay? And the type of bracket that we are going to have is this one, then 4 comma infinity, since we are just going towards infinity this side. So that is how you find A complement. I hope it was clear and straightforward. I'll be moving on to B. Find B complement. We draw the number line again. We have 0, 1, 2, 3, 4, 5, 6, 7, -1, -2, -3. Okay. And B, we're being told we have 2 is not included and 6 is not included. You get that from the type of brackets that are there. So this is our B. Okay, so how do we find B complement? B complement is going to be what is remaining, which is the part that is not in B. So since we have an open circle here, we're going to have a closed circle. In B complement, 2 is going to be included since it wasn't included in B. So we're going to have a closed circle going this side. So this is B complement. And even this side, closed circle going this side. I'm sure you guys have now seen the pattern. When you have an open circle, if you are doing something on top, it's going to be closed. If you have a closed circle, if you're doing something on top, it's going to be open. Okay. You can see here, here, even here, the same thing. If one is open, the one on top is going to be closed. So that's the basic idea. So now writing this, B complement is going to be equal to negative infinity, since we have negative infinity here, positive infinity the other side, comma 2, and the 2 is included. Since there's a gap, we introduce a union, and the 6 is going to be included in B complement, since in B it wasn't included, comma infinity, since we are just continuously going. Okay, so that's how you present, that's how you write B complement. Okay. The other part is A intersection B. Okay, we write our number line, negative infinity, we've got infinity, 0, 1, 2, 3, 4, 5, 6, 7, -1, -2, -3. Okay. So the first thing that we would like to do for us to find A intersection B, we first have to present A on the number line. And the A on the number line is going to look like this. So this is A, and again we have to present B on the number line. And B on the number line is going to look like this. So this is B. Okay. So now to find where these two intersect, we can see that the part where they intersecting is is here. Okay. It's this part. This is where they're intersecting. So what you're going to do is A union intersection B is going to be equal to the circle that you are going to pick is this one. So it's going to be this type of bracket. Then you have 2 comma, and what you're going to pick for the other side is this one. So you're going to have 4 also not included. So that's how you write A intersection B. And there's another part that is left, A union B. I'm going to leave it up to you guys to try to find A union B, and I hope you can give me the answer in the comment section. Try to see what you find will be the correct answer. All right. This was our first example on set build and on intervals. I'm going to see you in the next video. Bye bye.